This is USMLE QA, USMLE material presented in a question and answer format structured similar to the first aid for the USMLE Step 1 book.
Question: What is the Lac Operon? Answer: The Lac Operon is a classic example of a genetic response to an environmental change in which E. coli switches to lactose metabolism when glucose is absent and lactose is available. Question: How does low glucose levels lead to activation of the Lac Operon? Answer: Low glucose levels lead to an increase in adenylate cyclase activity, which in turn leads to an increase in the generation of CAMP from AT. This activates the catabolite activator protein, which leads to an increase in transcription. Question: How does high lactose levels activate the Lac Operon? Answer: High lactose levels lead to the unbinding of the repressor protein from the repressor operator site, which allows for an increase in transcription. Question: What is the mechanism of shift in the Lac Operon? Answer: The mechanism of shift in the Lac Operon involves the activation of the Lac Operon in response to changes in the availability of glucose and lactose. Low glucose levels lead to an increase in adenylate cyclase activity, which activates the catabolite activator protein and results in an increase in transcription. High lactose levels lead to the unbinding of the repressor protein from the repressor operator site, which also results in an increase in transcription. Question: What is the role of CAMP in the activation of the Lac Operon? Answer: CAMP plays a key role in the activation of the Lac Operon by serving as a signaling molecule that is generated in response to low glucose levels. The increase in CAMP activates the catabolite activator protein, which in turn leads to an increase in transcription of the Lac Operon. Question: Can you explain what is the repressor operator site? Answer: The repressor operator site is a specific region of DNA that controls the transcription of the Lac Operon. The Lac repressor protein binds to this site and prevents transcription when glucose is present, while high lactose levels leads to the unbinding of the repressor protein from the operator site, allowing transcription to occur. Question: What is the function of the Lac repressor protein? Answer: The Lac repressor protein is a regulatory protein that controls the transcription of the Lac Operon. It binds to the repressor operator site in the DNA and prevents transcription when glucose is present. The Lac repressor protein only allows transcription to occur when lactose is available and glucose is absent. Question: Can you explain the role of catabolite activator protein in the Lac Operon? Answer: The catabolite activator protein is a protein that activates the Lac Operon in response to low glucose levels. It is activated by the increase in CAMP levels generated by adenylate cyclase in response to low glucose. Once activated, CAP binds to the CAP binding site located upstream of the Lac Operon and promotes transcription. Question: What is the role of lactose in the activation of the Lac Operon? Answer: Lactose plays a key role in the activation of the Lac Operon by serving as an inducer that binds to the Lac repressor protein and causes it to dissociate from the operator site, allowing for transcription to occur. When lactose is available, the Lac Operon is activated and the enzymes needed for lactose metabolism are produced. Question: How does the Lac Operon control the production of enzymes for lactose metabolism? Answer: The Lac Operon controls the production of enzymes for lactose metabolism by regulating the transcription of genes encoding for the enzymes. When lactose is available and glucose is absent, the Lac Operon is activated and the genes encoding for the enzymes are transcribed. This leads to the production of the enzymes necessary for lactose metabolism. Question: Can you explain the concept of inducible operon? Answer: An inducible operon is a type of operon that is activated in response to the presence of a specific inducer molecule. The Lac Operon is an example of an inducible operon, as it is activated when lactose is available and deactivated when glucose is present. The presence or absence of the inducer molecule determines the transcriptional activity of the operon. Question: Can you explain the concept of constitutive operon? Answer: A constitutive operon is a type of operon that is always transcribed, regardless of the presence or absence of specific inducer molecules. These operants are constantly active and produce enzymes that are necessary for the cell's basic metabolic processes. Unlike inducible operants, constitutive operants do not require specific environmental conditions to be activated.
Thank you for watching our Q&A format video. We hope this helped you learn, review, and retain knowledge needed for the USMLEs. For more information on this topic, check out the link in the description. Now, if you want to take your USMLE prep to the next level, be sure to check out all our courses, which are structured to follow along with the first aid for the USMLE Step 1 book. You can find us at usmleqa.com. And if you're watching this on YouTube, be sure to like and subscribe.